The size of the universe is staggering. From barely visible debris to giant clusters of galaxies, this vast space contains an incredible variety of objects. Today we will embark on an exciting journey to the farthest reaches of the visible universe. Our expedition will begin at the center of the majestic Milky Way, where we will visit the dazzling core, delve into dusty nebulae and star clusters, and then venture into the cold and dangerous intergalactic space, pierced by destructive radiation. This journey will give us the opportunity to look into deep voids, see unusual galaxies, and approach the borders of the metagalaxy to look beyond the visible. Beginning, the center of the Milky Way. The Milky Way, our home galaxy, has been a mystery to humans for millennia. Even before telescopes were invented, people observed a streak of light crossing the heavens that inspired myths and legends. However, it was only through scientific progress that it became clear that the Milky Way is the light of billions of stars too distant to distinguish individually. At the center of the galaxy is a supermassive black hole, Sagittarius asterisk. It has a mass of 4.3 million solar masses and a diameter of less than 16 million kilometers. Observations through radio telescopes and model calculations have confirmed the existence of this object. Around Sagittarius asterisk is concentrated a huge number of stars and dust clouds. These regions are a kind of heart of the galaxy, radiating energy and setting the dynamics of its evolution. Interesting fact: around the black hole are moving stars with incredible speeds. For example, the star S62 at its minimum distance is only 17.8 astronomical units away from the black hole, traveling at 6.7% of the speed of light. The galactic disk, the abode of stars. The Milky Way's galactic disk is where 80% of the mass of visible stars is concentrated. It is home to both young luminaries and ancient stars, accompanied by giant clouds of interstellar gas and dust. These regions are often called stellar factories because new stars are actively forming in them. Spiral arms, such as the Orion arm to which the solar system belongs, are the most prominent elements of the disk structure. However, the disk is not only the domain of life. It is also home to the remnants of ancient galaxies that were swallowed up by the Milky Way. For example, the hypothetical galaxy Enceladus contributed to the thicker component of the disk and brought billions of stars into the disk. Intergalactic space, the cold void. Beyond the galaxies begins intergalactic space, which at first glance appears empty. However, it is filled with ionized gas, including atoms of hydrogen, oxygen, and other elements. This gas, left over from the Big Bang, is the raw material for the formation of new stars and galaxies. You can also find runaway stars that were ejected from their galaxies. Interesting fact: intergalactic space contains more mass than all the galaxies we see combined. It plays a key role in shaping the structure of the universe. Giant voids and unique galaxies. Giant voids exist between galaxies, such as a local void 150 million light-years in diameter. These areas are virtually devoid of matter, but sometimes single galaxies can be found in them, such as NGC 6503, which looks like an island in the darkness. At the same time, some galaxies stand out for their unusual nature. For example, the Baby Boom galaxy, where about 4,000 stars form each year. The role of dark matter and energy. Dark matter, which makes up about 85% of all mass in the universe, remains one of the major mysteries of modern science. Although invisible to telescopes, its existence is confirmed by its gravitational influence on the motion of galaxies and the formation of the large-scale structure of the universe. Dark energy, in turn, is responsible for the accelerated expansion of the universe. These phenomena play a key role in the evolution of the cosmos. Interesting fact: dark energy makes up about 68% of all energy in the universe, making it the dominant component. Exoplanets, the search for new worlds. With the help of modern telescopes like the James Webb, scientists are actively exploring exoplanets and their atmospheres. This brings us closer to discovering potentially habitable worlds beyond the solar system. By analyzing the spectra of stars and planets, we can learn about the chemical composition and temperature of their atmospheres. Interesting fact: more than 5,000 exoplanets have already been discovered, and some of them are in areas where liquid water may exist. Boundaries of the universe. The observable universe is bounded by the horizon of light that has reached the Earth in 13.8 billion years. However, other worlds may lie beyond this horizon. Modern research, such as the work of the James Webb Telescope, continues to expand our understanding of these boundaries, finding ever more distant galaxies and large-scale structures. Interesting fact: the James Webb Telescope provides a glimpse into the past by observing objects that existed just 300 million years after the Big Bang. Traveling to the boundaries of the visible universe is not only a scientific exploration, but also an opportunity to reflect on your place in it. By observing the scale and complexity of the cosmos, we become more aware of how unique our planet and our lives are. Studying the universe helps us not only to understand its structure, but also to find answers to questions about our origins and future. The world beyond the horizon remains a mystery, and that is its magic.